Life on other planets. The idea has fascinated man for ages. The discovery of Earth-like planets with life-sustaining water and air may come one step closer through NASA's Kepler mission. When the Kepler spacecraft launches from Cape Canaveral Air Force Station in Florida aboard a Delta II rocket, it begins a quest in our part of the Milky Way galaxy. The spacecraft will orbit our sun as it focuses on 100,000 stars that may be orbited by their own inhabitable planets. From NASA's Kennedy Space Center in Florida, join us now as we focus on this exciting mission and prepare for liftoff.
Hi, thanks for joining us. I'm your host, Tiffany Nail. I'm here at Kennedy Space Center Visitor Complex in Florida. This area is known as the Rocket Garden. It's dedicated to the massive giants that have soared into space over the years. Here, the public can get an up-close look at these incredible rockets. This place can be especially inspiring to students. But even if they can't visit, students from across the country can learn more about NASA through our digital learning network. So we decided to give a group of those students a chance to ask the questions for today's program. Here's Damon Talley from the Digital Learning Network to introduce you to the class.
Thanks, Tiffany. Hello, and welcome to the Digital Learning Network. We're able to connect with classrooms all across the country, and today we have a special link-up with Sharon Bain's 7th grade classroom at Pine Ridge Middle School in Naples, Florida. Hello, everyone.
Good morning. Good morning, Mr. Talley and NASA. We're certainly happy to be with you this morning. We have some great questions for you.
Great. Well, we'll get to those questions in just a few minutes. First, let's learn more about Kepler from Kepler mission scientist Dr. David Koch, who stopped by the NASA Direct studio recently.
The Kepler mission is specifically designed to look for Earth-like planets going around other stars, stars like our sun. Kepler is designed to find things like Earth. That you can't do from the ground. You have to go into space. The Kepler mission consists of just one instrument. This is not a facility for the general community. This is designed to do just one thing, and that is to look for planets going around other stars. And the way we do that is with an instrument we call a photometer. It's a general purpose kind of telescope, but a special kind of telescope. It's called a Schmidt design. It has a very large field of view. We need to look at a lot of stars. We're going to look at over 100,000 stars at once with this mission. Our telescope field of view is about equal to taking your hand at arm's length, hold it up to the sky. Also equal to about 2 dips from the Big Dipper. With that, we can now see lots of stars, and then we can look for planets around those stars. The way Kepler works is it looks for transits. That is, a planet passing in front of the star and blocking a little bit of light. As we look at that star, we don't see the planet, we just see the starlight dim for a few hours as the planet goes in front. One transit, though, isn't enough. What you need is to see a sequence of transits. The first one and the second one give you a period, but only if you see that third one at exactly the right time do you know you have a planet orbiting that star. From the period crossing the starlight, crossing the face of the star, you can get the distance the planet is from the star using Kepler's third law. We named it after Kepler, the man who discovered the laws of planetary motion. We are going to operate this mission initially for 3.5 years. That's the baseline mission. It's been designed to operate for at least 6 years. The reason we have to look for 3.5 years is we're looking for a sequence of transits. To get the data down, we have an antenna on the side of the spacecraft that has to get pointed to Earth. So once a month, we have to point away from looking at our star field and point that antenna so it beams the data down to Earth. So once a month, we'll get that data. Boy, what we get out of this mission is going to open our eyes, maybe change the way we think. We're going to look at 100,000 stars. We expect to find hundreds of planets. What if we get one? What if we get 0? That would be an eye-opener too. We'd have to think, are we alone? Is life unique? Are there no other beings? We won't know that until we get an answer from this to ask the next question about life, but at least we'll have the answer, are there planets like Earth somewhere out there?
Thanks, Dr. Koch. Before the Kepler spacecraft can start its mission, it has to get into space. Let's take some questions now for our NASA rocket scientist, Armando Piloto, who will also answer them from our NASA Direct studio. Who has a question?
Hi, my name is Sheila. Did you always want to be a rocket scientist?
Hi Sheila. Actually, as a kid growing up, I dreamed of launching home runs in a baseball field and not necessarily launching rockets. Playing baseball is what I wanted to do. But obviously, I have a great job here at NASA. I am very dedicated to what I do. And to be able to be part of the Kepler mission and be able to work with rockets is a very rewarding and phenomenal experience. And I'm definitely looking forward to the successful launch of Kepler. So to answer your question, no, but I definitely love what I do now.
Hi, my name is Otto. Where do you sit during a countdown?
Hey Otto, during launch day, during terminal count, I sit in the Mission Director Center, together with the rest of the NASA management and ULA management team. The Mission Director Center is actually located approximately 2 to 3 miles away from the launch site. And the MDC, as we call it, is equipped with all kinds of data displays, video screens, and communication networks to enable the management team to determine the health of the spacecraft, the health of the launch vehicle, and ensure that all systems are ready to proceed with launch.
Hi, my name's Loudon. I was just wondering, what kind of fuel does a rocket burn?
That's a great question. The fuel that we use on the rocket is dependent on what rocket we're using. For Kepler, we'll be launching aboard a Delta II vehicle. And the first stage of the Delta II burns a combination of liquid oxygen and RP1. RP1 is essentially a highly refined kerosene.
Hi, my name is Andres. How do you know what kind of rocket to use?
Okay, determining what kind of rocket to use is based on a number of different factors, including cost, schedule, technical requirements, and risk. But primarily, there are 2 main factors that we consider: the size of the spacecraft and also the orbit where the spacecraft needs to be delivered to.
Hi, I'm Kelly. What should I study if I want to become a rocket scientist?
Hi Kelly, I'll tell you what I study. I have a bachelor degree in mechanical engineering and a master's degree in engineering management. But my advice to you and to the rest of the kids that want to work with rockets is to, first of all, do good at math and science so that you can develop strong analytical skills. I would also encourage you to take classes in speech and debate so that you can also develop strong communication skills. I think it's also very important that you get involved with team projects and team sports so that you can learn to interact in a team environment. And then once in college, I think it's important to earn a degree in either physics, science, engineering, or math. I think the combination of strong analytical and communication skills combined with one of those degrees will open a lot of opportunities for you, including opportunities to work here at the Kennedy Space Center working with rockets.
Well, that's all we have time for. Thanks, Mrs. Baines and your students, for all of your help today.
Goodbye now.
Now back to your host, Tiffany Nail.
Thanks, Damon, and thanks to all our guests for helping us learn more about this exciting mission of Kepler. You can follow the countdown on NASA TV and on our live launch blog at nasa.gov/Kepler. From the Rocket Garden at Kennedy Space Center, I'm Tiffany Nail.